Yeah, are we good to start?
Uh, yes, hi everyone. Thanks again for joining today's session on near real-time analytics with Azure Synapse. Today we have our guest Sagar La, who is joining us, and he is a Microsoft certified trainer, and he is going to be walking us through how you can do the real-time analytics with Azure Synapse, and he will be sharing more himself and getting into the session. So before I move the mic to Sagar, I would like to say that two things about today's session, that today's session is recorded and it will be available in our YouTube channel. Secondly, there is certificate of participation for the today's session. In order to receive it, you need to stay till the end of the session to fill out the form and receive it. And if you're joining us for the first time, we are conducting these kind of webinars and trainings in our community. You can join the community by clicking on the link in the chat box, and you should be there. And that's it from my side. And without any more delay, let's get into the session. Over to you, Sagar.
Yeah, thanks a lot, Surak, for the lovely introduction. So, hi everyone. Thanks for joining the session. Today we are going to discuss about near real-time analytics using Synapse. So, the agenda for today's meeting is first one is we'll have a brief introduction to the Cosmos DB and Synapse Link. Then we will look at the end-to-end real-time analytics with Azure Synapse for Cosmos DB. And at the end, if we have any query, we can pick it up. You can post your queries in the chats. Yeah, so that's the agenda for today. So first of all, I mean, if you want to enable near real-time streaming, then why do we have to use Cosmos DB and Synapse Link, and what are the current challenges? So there are. Let's look at the challenges with the traditional analytics workload with normal Cosmos DB. So as you know, Cosmos DB is an offering from Microsoft Azure, and it provides multiple APIs like Gremlin API, NoSQL API, or Cassandra API. But there are a lot of disadvantages. The first one is manipulating the amount of provision throughput. We have to use change data field to move the data to Cosmos DB, and the developer has to develop a custom ETL mechanism to move the data to Cosmos DB. For example, if you are getting the data in ADL Agento, and if you move the data to Cosmos DB, then you have to write a custom code. And also it takes some processing time and cost to move the data available to Cosmos DB. Now, in order to overcome these challenges, we can use Synapse Link of Cosmos DB. So with Synapse Link for Cosmos DB, it will enable analytics over the transactional data without impacting the transactional workload. Another benefit is that this Cosmos DB Analytics Store, it is an inbuilt feature of Synapse Link for Cosmos DB, which will allow to sync the transactional data into the column store. You don't have to develop any custom or a complex logic to manage the ETL. So whenever there is a data, if you have a Synapse Links enabled for Cosmos DB, the data will be automatically ingested to the data will be automatically ingested into the Cosmos database, and we can enable near real-time analytics with the data. Now, Cosmos DB. What is Cosmos DB? Let's also take a brief look. So, Azure Cosmos DB is a Microsoft global distributed multi-model NoSQL database that allows us to elastically and independently scale in terms of throughput and storage. So in Cosmos DB, it provides multiple offerings. So it has SQL and it has document database. So we can use SQL and a MongoDB API. We can use key value data using table API. We can use columnar data with Cassandra API, and we can also use graph data with Gremlin API. It also allows us, with this Cosmos DB also allows us to build the highly responsive and available applications worldwide to ensure that data is as close as possible without any additional delays for both read and writes. And another major feature of Cosmos DB is that it also provides multiple consistency model like strong bounded staleness session, consistent prefix, and eventual, which will provide more flexibility to choose the consistency and how to handle the data. Synapse is also an offering from Microsoft, so it is an integrated analytics service that allows to use SQL and Spark for your analytics and data warehousing workload. So basically, it provides an unified platform where we can work with the data, we can set up a pipeline, we can work with the pipelines in Spark. We can also use SQL to run the queries. So it's a unified platform which has everything basically in it. We can build the pipeline for data integration, ELT, and machine learning purposes. We can also integrate Azure Synapse with other services like Azure ML, Power BI, and Cosmos. So, for example, we can build the ETL pipeline in Synapse, and once data is ready, if you want to prepare a report, you can build the reports in Power BI. And Azure Synapse also has a Synapse Studio, which enables data engineers, BI engineers, and data scientists unified experience to build the analytic solutions. Now, after we got a basic understanding of Cosmos DB and Synapse, let's see what is the Synapse Link feature of Cosmos DB. So Azure Synapse Link for Cosmos DB is a cloud-native transaction and analytic processing capabilities that allows us to enable near real-time analytics over the data in Cosmos DB via this analytics store. So it provides it enables us to ingest data in a real-time manner without performing any ETL pipeline. So this is the Cosmos database. For example, you have set up a Cosmos database with the table API. On the top of that, you have to configure Synapse links. As soon as you configure the Synapse link, this Cosmos DB analytical storage will be enabled, and then the data will be ingested and made available automatically without writing any complex logic. This Cosmos DB analytical store is an isolated column store which allows to perform analytics against the transactional data without impacting any transactional workload. So basically, it is a raw store which is optimized for transactional reads and writes. And it is also schema agnostics. For example, you are loading a data right now which has 5 columns, and in future you will receive the same data source with maybe 10 columns. Then without doing any changes to the Cosmos DB schema, you will be able to ingest data, and it allows also to do the iteration on the application without having to manage the schemas and indices. So the schema drift and the indexes are an out-of-box capabilities of analytical store with Cosmos DB. Additionally, this feature also helps to perform the super fast transactional reads and write with Cosmos DB. So what we can do is once the Cosmos DB is configured with Synapse Link, we can easily extract the data out of Cosmos DB in a separate layer to to perform various kind of analytics and also to enable the change feed. So these are the benefits. Uh, Apart from this, it can also help us to sync the operational data into the raw store into a separate column store to perform the analytical queries without building the ETL pipelines. With this, we can also enable analytical store on containers inside Cosmos DB to set up an isolated column store based on the operational data inside the transactional store. And the data will be automatically synced. So we no longer need to use chain data feed or develop a custom mechanism. For example, if we want to maintain the history of data, then this is an out-of-box feature of this Cosmos DB with Synapse Link. We don't have to write any Python code or a PySpark code to maintain the history of data. Then autosync will be enabled regardless of the intensity of the transactional traffic without impacting the performance. In the analytical store of Cosmos DB, there are two modes: well-defined schema representation and full fidelity schema representation. In the well-defined schema representation, it provides a tabular version of the data in the transactional store, while full fidelity schemas handle the full breadth of schema that exists in the transactional data. So in the well-defined schema, properties in the documentation always have the same data type, and the array type and any array type must contain a single repetitive type. But in the full fidelity schema, there is no such constraint. So when the analytical store is enabled in SQL API account, the default is well defined, but in the MongoDB API, the default is full fidelity feature. Now, let's also look at from practical point of view how we can enable Synapse links for Cosmos DB. So first of all, the Cosmos DB account should be there. Once the Cosmos DB account is deployed, if you go to the Cosmos DB Data Explorer scheme, Then on the top of the screen, you will have an option to enable the Synapse link. Now, once you click on this enable Azure Synapse link option, it will take couple of minutes to effect, and once that is done, we can go through the remaining process of setting up the container to use the analytical store. Now, let's see how we can set up the container to use the analytical store. So first of all, you have to go to the Azure Cosmos DB container via the Data Explorer, which we have enabled the data, for which we have enabled the analytical store. Now click on a new container. Once you click on a new container, then the pop-up will up. Then there will be a pop-up. You have to provide a container name, partition key. You have to select the throughput. It can be manual or an auto scale. If it is auto scale, then you have to provide a maximum request unit. So request unit are the processing unit when the data processing is done within a Cosmos DB. And here you have an option to whether you want to enable analytical store or not. So if it is off, then analytical store will not be created. If it is on, then the analytical store will be created. Now, once the container is set up, then we have to set up the container. These are the additional properties to set up the analytical store for the container. So, time to leave option, for example, till what time you want to set whether you want to enable time to leave option or not. So you can configure it here. The geospatial configuration, so for which geography or geometry you want to enable this configuration, and any analytical storage time to live. So, for example, when we are storing or processing the data, in between during the processing, we are creating some temporary data. So, until what time you want to maintain this data into the analytical store, so we can configure it in this setting. Now, let's also explore a bit more in detail about the analytics time to live. So, time to live feature for analytical store states that how long the data should be there in the analytical store. And this setting is isolated from the TTL setting we have set for a transactional store. Since these two settings are different, data archiving become very simpler for us. So, the analytical store is optimized in terms of storage compared to the transactional store. We can retain the data for a longer period of time in analytical store by setting the analytical TTL to at a longer in retention interval than that of a transactional store. Now let's see how we can connect to Cosmos DB from Synapse. So first of all, you should have a Azure Synapse instance ready. Once the Azure Synapse instance is ready, we have our container for which the analytical store is enabled. We have to go, if you do not have a Synapse instance created, then you can follow this link to create an Azure Synapse. Now, once the Azure Synapse is created, you have to go to the Data Object Explorer in Synapse, and then you have to click on a plus button, and there you have an option to connect to the external data. Now, as soon as you click an option to connect to the external data, you will get a pop-up where you can select different type of external connectivity. So you can connect to blob storage, you can connect to Cosmos DB, you can connect to Cosmos DB with SQL API, you can connect to Data Explorer, and you can also connect to ADLS Gen 2. So in order to use Synapse Link for Cosmos DB, we will choose one of these. So based on your scenario or a project, you can choose MongoDB API, or we can use SQL DB API. Now, once you select one of these options, then you will again get a pop-up where you have to create a link service. So link service is basically a connection endpoint or a connection bridge to connect between Synapse and Cosmos. So you have to provide a valid link service name, description, integration runtime. So by default, it is an auto-resolve integration runtime. So basically, we'll be using the compute provided by Microsoft Azure. And then the selection method, so which Azure subscription and the Cosmos DB account do you want to choose. Based on that, you can configure the Cosmos DB to connect from Synapse. Now, there are two type of containers in Cosmos DB. So we have OLTP only containers, and we have H-step enabled container. So we can differentiate between the container that have analytical store enabled on them for those that do not have a different icon. So if this icon is enabled, then the analytical store is not enabled. So it is an OLTP container. If this analytical symbol is present in the icon, then it is an H-step enabled container. So now, once we identify or distinguish between the analytical store enable container, we have to create an Apache Spark pool. So in order to do that, you have to go to Synapse and then click on Create Apache Spark pool. Now, once you create it, then this screen will pop up, and here you can create a Spark pool or a SQL pool. But here we want to create a Spark pool, so we have to select the Spark pool and then click on New button. This will create a Spark pool. Now in the Spark pool, we have to provide configuration. So you have to provide a valid Spark pool name, the node size based on your requirement, whether you want to enable auto scale or not, and the number of nodes based on your workload. Now, once you provide all this configuration information and click on a create button, and then the Spark pool will be created, but it will not be published. So in order to use this Spark pool for future purpose as well, we have to click on a publish all button, then the pool will be created. Then, in order to take an actual end-to-end example, here I'm taking an example of a JSON file which is coming for a simple device reading container, which has 10,000 document, and each document has this format. It has ID, temperature, damage level, age in days, and location. Now let's try to process this using Synapse, with the Spark pool that we created. So this is the this is the PySpark code. So I'm using spark.read.format cosmos.olep because it is an olep enabled container. We have to use the link service which you created in the previous step, and then the option is the device reading. So in the device reading container of a Cosmos DB, I want to read all the data and I want to store it in a PySpark data frame. So in this data frame, we will have all the data. Now, when I display the data, when I display this data frame, then you'll be able to see all the data which is present in the JSON file. So we have RID, we have timestamp, we have ID, we have temperature, damage level, age in days, and location. Now let's do some ETL processing as well. So I want to get rid of RID, TS, and ETEC from the previous column. So once I run this command in the Spark pool, this df underscore clean will only contain this data. So it has ID, it has temperature, damage level, aging days, and location. Now, the next step is now we have prepared a data frame which is cleansed with the help of Synapse. And now what we want to do is we have a column where we want to do some aggregation, and we want to display the data based on the ascending order of age in days. So I'm creating a new data frame df old days devices, where I'm doing the order by based on age in days in a descending order, and then I am only displaying the limited 10 records to see how the output looks like. So yeah, this is how we can use Cosmos. We can use the Synapse link for Cosmos DB to enable near real-time ingestion, and this data can be directly used for the analytics purpose. Now, currently, I have just demonstrated the capability of being able to query the analytical store in Cosmos DB using Spark in Synapse without affecting the transactional workload. But that is not, we are not just limited to querying the data. We can also query the data using T-SQL, using serverless SQL pool. When we provision the Synapse, we immediately have a serverless SQL pool available to us. Now, there is also a cost involved when we additional cost involved when we use Synapse Link for Cosmos DB. So when using Synapse Link for Cosmos DB, you have to pay for both analytical store in Cosmos DB as well as paying for the Synapse Analytics as well. This analytical store follows the consumption-based pricing model. So you are charged for the storage retained in the analytical store for both analytical read and write operation. While pricing is separate from the transactional store, you don't have to provision request unit as you would do it in the transactional store. But there are also some limitations of using Synapse Link with Cosmos DB. So currently the Synapse Link for Cosmos DB is only available for SQL and MongoDB API. For any container with the analytical store enable, automatic backup and restore of the data in the analytical store is not currently supported. If you need to restore the transactional store, the container will be restored without any analytical store enabled. Yeah, so that's the end of my presentation. Yeah, if you have any query, we can pick it up. Otherwise, over to you, Suraj.
Thank you, Sagar, for the explanation. And I think there might be a few questions in the chat box if we can have a look at it.
Yeah,
There
so
is
there
one
is a
question.
question from Sanya. Is this process also captured in new Microsoft Fabric? From my understanding, the Synapse is captured under Microsoft Fabric. Also, is Cosmos to be used in Fabric? As I learned that every data goes to the lakehouse. Yes, so actually, this Microsoft Fabric is a new concept, and both Synapse and Cosmos DB are captured in the new Microsoft Fabric. Yeah, someone is asking for a presentation. So yes, I will share the presentation with you, Surag, and then you can share it with everyone.
Yes. We'll be waiting 5 minutes because people might be typing their question so that they can ask the question. So we'll be waiting next 5 minutes so that if in case you guys have any question. So since we are done, we have the next action for you to be joining our community, where you can have more sessions coming up, and we'll be having more sessions and training in the community. So be sure to be there so that you will get updated about it. We'll be sharing the certificate link pretty soon in the chat box. Please do stay in for the next 5 minutes, where we'll be sharing about it pretty soon. Mm. Sagar, if you can see, there is one question in the chat box.
Yeah, sorry, there is a question from Muhammad Ali that can Synapse work with no relational database? The answer is yes. So we can also use Synapse to work with NoSQL or non-relational database like Cosmos DB or any other database, MongoDB.
Okay. So if that's only the question that is remaining, okay, we can wind up today's session. Thank you all for joining, and thank you, Sagar, for sharing his knowledge with us. And I hope you were able to, have a complete idea of it, so you have the, idea about how to go about it. So you can check out the Microsoft Learning itself to know more. That's it. Again, thank you for Sagar and taking his time to share his knowledge. And I have shared the link for the certificate of participation in the chat box. That is pretty much a Microsoft form. You can fill it out to receive your certificate of participation. Again, thank you all for joining, and it's probably evening there. And thank you all, and have a great rest of your week and next. Thank you.
Yeah, thank you. Bye.
Thank you. Bye. And it will be uploaded in our